Hello and welcome to this week's exercises where you will be working with strings and loops. And in particular, loops are a very important construct in all programming languages and in particular in Python that allows you to repeat tasks. So I think for many of you this will be the first exercise where you'll really feel that you're starting to learn how to actually program and not just evaluate expressions in the Python interpreter. But before I get there, I think I should mention that the same that I said last week applies this week. So these videos are not supposed to be an alternative to the lectures, and it is important that you try to complete the exercises yourself before you perhaps look at the videos. Otherwise you won't get any benefit out of the exercises. That's my experience at least. So before I get started on the exercise, I want to zoom out a little bit and talk a little about the components of the course, because I got a lot of questions about that on Discord. So why are you learning to program in the first place? That has to do with the Polytechnical Foundation, but what does that really mean? So I think that the courses here at DTU can be divided into three categories. The first is mathematics, and mathematics teaches you about abstract reasoning and deduction, so a way of making logical arguments and describe things in great details. That's really the language of engineering, and that's why it's important. It changes how you can think about the natural world. The second group of courses are the natural sciences, so physics, chemistry and biology. And these tell you how to, these give you a description of the world. They tell you how the world actually works, and that's why they're important for an engineer. And then, as a new thing in the Polytechnical Foundation, we have programming. So what is programming really doing there? Well, programming is what makes the other groups practical. So these days, pretty much everything we do in mathematics and physics and chemistry and so on that has to do with engineering eventually involves computers and therefore programming. So that's one of the reasons why these courses are important. The other reason is that programming has a personal importance to you at the very least potentially. So programming will allow you to automate a lot of mundane tasks that you will today try to carry out manually in an Excel sheet or something else. So programming has the potential at least to make you a lot more productive, and you will actually be able to unlock that potential when you're done with this course. So I think that's the second reason why programming is important. So how do we put programming, what's our philosophy behind teaching programming in this course? I think I can summarize it as this. We want you to be able to write programs that are correct, and this has to be a real life skill that you have. And I think that touch on the things that I mentioned earlier. So first of all, you need to actually be able to program. Correctness is because you want to apply this to engineering, and in that case it's important that your programs are correct and work as expected, because otherwise it can potentially lead to very costly or dangerous situations. And real life is also important, because this is a skill we want you to take with you and be able to apply in your other courses and also in your private life, just to make your life easier by automating some tasks. So we end up with these three pillars of knowledge that you need to gain. You need to be able to learn something about Python. Then you need to learn something about correctness. So how do we actually verify and ensure that a program is correct or solve problems in a program? So that's the pillar I call testing and debugging. And the last pillar relates to real life. So you need to actually be able to install and run Python in a realistic situation. So we could simplify this course a lot potentially by, for instance, telling you to just run Python in a browser, which is possible. But that would not be a skill that would be transferable to a real life situation. Okay, so now we are 4 weeks into the course, and you have had 3 weeks of experience with the exercises, and I think it's a really good time to sort of look at these pillars and reflect on how you've seen them so far and how you're going to see them moving ahead, for instance in this lecture. So the first one is how to write programs, and this is basically what all the main course material relates to. So that's the book, it's the exercises, is the thing that I think most of you associate with something fun or relevant for the course, like you actually do want to learn how to write Python code. So it's probably also what you sort of expected would happen in this course. And that's why I've given it the luxury POO. This is like the time where we hope that you have a good time because you're working with exercises and projects that feel relevant and you feel you're like learning a lot of good book knowledge and getting smarter. There are also the other pillars. So for instance, we need to think about correctness. So correctness is very interesting in programming because the notion of correctness you are used to probably is one you associate with mathematics, right? Like you need to do some mathematics for a test or problem or something else. And in mathematics, there's this funny thing that if you write a piece of mathematics and it contains one problem, it's wrong. And that's just it. And that's the kind of feedback you get. Like there's a problem here on this line, so just do it over again, get better. And there's not a lot more reflection or process behind that answer. It's just how it is. And that's also the way it is when I do mathematics. It needs to actually have zero mistakes to be of any values. So that's what I sort of like put in here as a joke, because in programming, that's not the attitude that you should actually have. And this is a very important point if you want to become good programmers. So in programming, mistakes are the norm. It's what we actually spend the most time trying to fix when we program. Like when I develop something, I spend fairly little time actually writing new code, and I spend most of my time going over my old code and trying to solve problems or figure out what goes wrong or why it doesn't exactly do what you want. And you're probably familiar with that for computer games, where like errors are just what happens in computer games. And that will be the case for all your code today and in 10 years. I can simply promise you that. So why is it so hard to avoid mistakes in programming? Well, first and foremost, programming is also hard. Like it's just not a super easy thing to do. The second thing has to do with knowledge, in my opinion. So often we don't know there is a mistake when we are making it. It's only after some time when we run our program or test it in an unexpected way that we discover, oh wow, the horse goes on the roof when you call it. The other reason is that sometimes we change an aspect of a program and then a mistake crops up in a different place because that part of the program relied on the other part behaving in a certain way. And that's the most difficult mistakes to find, because you don't expect them to happen, and it's something this used to work and all of a sudden it breaks, and it can really frustrate you. So that's another thing that happens, and I think many of the problems in a computer game has a little bit to do with each. If you think about those two problems, they all have to do with lack of information or awareness that there is a mistake in your program, and that is what you need to really focus on here. So for instance, if we had tried to call the horse and checked if the horse was on the roof and then printed out a warning for us while we were writing this code, we would have caught this mistake early on, or developer, Bethesda would, and they would have been aware that, okay, that's something they need to go in and fix. Oh, by the way, this is not Bethesda, sorry, I forgot that. Anyway, that's aside the point. So this is something that we need to deal with and we need to get better at, and that's why I've given it like the basic POO, because it's something that's just super important. It's not particularly fun, and I think basic POO sort of fits here. So how do people fix that in real life? Well, people actually like spend a lot of energy addressing this from a management perspective, and it all revolves around this idea of making the problems visible to people as early on as possible and in a systematic fashion. And that's where testing comes in. So the only way we really know how to address these problems today is by using a lot of tests. So a test is basically that you start out with an idea of what you program, then you describe a list of behaviors you want your program to behave. So when you give your functions or whatever it is some sort of input argument, you reason your way towards what it should do, so it should respond with a why. Then what you do is that you automatically check these behaviors. So you write a small program that's only designed to test whether your program does the right thing when you give it X. And that's called a test in programming. Then you run the tests as often as you possibly can, and whenever you see a problem, you go in and fix it. if a problem occurs that you didn't expect, so if you all of a sudden see the horses on the roof, you add a test that tries to provoke the horse to get on the roof. So you like have a process to figure out what was it that went wrong, and you write a test that sort of warns you if it ends up on the roof. And that's called a test. And that's what people do in test-intensive development cycles. And then you sort of just repeat this cycle until your programs work in an acceptable way. This way of working is called test-driven development. So we're doing this in this course. The drawback of test-driven development is that it takes some time to write the test, but we've done that for you. So when you work with tests in this course, and the reason why I refer to it quite a lot, you're actually working with the real-life industry-grade interface for verifying tests. And the reason why we chose that and not some like online autograde or online verification system or something ad hoc is simply because we think this is in itself an important skill, and we might as well train you in a real-life situation to use tests and use tests to find problems. I included a link here below from another video games blog that describes how they use tests in order to arrive at a correct implementation. I think it's actually a really interesting blog to read, and I think it will be interesting for many of you. Then we get to the last thing, namely that this is a real-life skill that you need to be able to do in real life on your own laptops. So that's why we've chosen VS Code. So VS Code is a complicated program. You all sort of discovered that by now. It has a ton of buttons, but it can do a lot of really nice things that can make us much more productive. So for instance, one of the things it can do is that it can automatically discover if we make mistakes like spelling errors and so on, that results in code that cannot run. So that's what all the squiggly lines and red dots or whatever, that's what that signifies when you sit and write programs. It's usually something that you need to look at a little bit. VS Code is also really good at trying to telling you what the problem is. So if you do mouse over on these problems, it'll actually tell you, okay, there is a problem here potentially. Another thing Visual Studio Code can do is that it can give you hints about function names and other things that you can potentially do. So that's a reason why I'm actually able to program at all, because I don't know that much, but I can do this in Visual Studio Code. So now I'm just changing over to code. So let's say that I open some random file here. So let's open this one. Then what you can do is that you can import a module like math, and then you can do math dot, and then it will also complete. And Visual Studio Code has a lot of functionality that function like this. It'll tell you what is available. So if I want to do something, then I can go down here and say, okay, this one is probably computing the factorial function. Floor, that typically has to do with rounding. Gamma, that's the gamma function. You'll see that in mathematics maybe next semester. And then there are other options available. And that can really often be a big help if you have something you want to do and you don't quite know what to do. You can also do this same thing on strings, and then you can see, well, there is apparently a capitalize function, and I wonder what that does. Well, let's just try to test it by starting Python. And then we see that what it does is that it capitalizes a word. So that's like a neat thing that we can apparently do in Python. And all of this is something that I can sit here and discover using VS Code. So let's just remove that and quit the interpreter. Okay, back to the slides. Then the last thing is that you actually have access to a tool that we haven't talked about at all until now, called the debugger. And I think I'll start to use the debugger today because it's a really useful tool if you want to fix problems in your code. And it's something that becomes more and more relevant for you the more complicated your code becomes. And I think this is a good time to start using it. It's a little bit optional to use, but it's one of those things where it's like you want to be a carpenter, and this is a power tool, and you have either the ability to use a manual screwdriver or power tool when it comes to solving your problems. And I would just recommend spending a little time to try to use the power tool. So for instance, here we can see that this is an example of what the debugger looks like. It has stopped on this problem, it highlights there's a problem, and it actually also writes out what it thinks is the problem. So it says this variable is not defined. Well, it's not defined because it's spelled wrong. Okay. Unfortunately, and this is why this earns the luxury poop. But now we come to the ugly, and that is that in order to run things on your computer, you need to relate to your computer. And your computer is not always such a nice place. So the problem here, and many of you have encountered that during the installation procedure, is that when you want something like Python to interact with your operation system, that tends to create conflicts and problems simply. It just, programming languages and the operation system, it's not really a problem that people have fixed in a very good way so far. This is a problem in all programming languages, and it manifests by, for some it just works, you can just install Python and it works, and for some there is like an endless series of small annoying problems that you don't really know how to fix, and then a TA comes over and it's something like you open the wrong folder or something else that's stupid. And that's why this one earns the derpy poo. It's a joke in Python that things are complicated. This is maybe a little exaggerated. It's also a little old, so it's a little bit better today, but it's still kind of true, unfortunately. This is, by the way, on Mac, so yeah, good luck. So the reason why we put you through all of that is simply because we want this to be a real life skill. And if you worked on this in the browser, you would learn how to program in the browser, but it wouldn't be a skill you could easily transfer. So that's basically the decision that lies behind trying to address this heads on at once, and then hopefully it won't be a big issue for you later in your engineering studies. So regarding that, we have the change in the hand-in. So far, it's around 1% who has used the ability to hand in as a Python. As Python files. I would really recommend that the people down here try to set up their computer correctly. I can simply see on the hand-ins that many of the people who hand in here have small silly mistakes that the testing system would point out to them, and they would be able to correct it and then get a high evaluation. So if you are down here in this category, or you expect to be down here in this category, please contact Python support, contact your TA. If all else fail, contact us. Just like get your problems fixed. It shouldn't take more than a handful of minutes, even in the worst cases, and then it's over, done. You don't have to worry about it for the rest of the semester. So what I want to do today is basically I want to talk a little bit more about VS Code, some of the issues that I saw last week, and this is sort of going to continue my series on how to identify and fix problems in VS Code that I started in week 3. Then I want to talk a little bit about the debugger as I work through the exercises, basically just talk and type my way through the exercises. Maybe I won't do all the exercises this time. I felt it took a little too long last time, and I could see that people weren't watching all the videos, so maybe that's a bit superfluous to do all of them. Then I want to talk a little bit about Project 2, and that's it. And as usual, please try to solve the exercises yourself. Don't just watch these videos. If you have any comments or suggestions or questions or anything like that, you can typically find me on Discord, and there is a link on our course web page. So thanks for your attention.